This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 5, Lesson 7, Beams, Trusses and Frames. This is the structural assembly lesson, and it rests on one idea: statics. Every member force in a truss or a frame comes from force and moment equilibrium. Beams you already built in Week 1, so those are a quick recap. We'll set the equilibrium foundation, contrast two force and multi-force members, then work a truss by joints and by sections, and finish with a frame pin reaction. Concept 1. Everything is equilibrium. A structure at rest gives you three scalar equations per free body. Sum of forces in X, sum in Y, sum of moments, all 0. Two definitions carry the lesson. A two-force member is loaded at only 2 points, so its force is purely axial along the line between them. That's every truss member. A multi-force member takes 3 or more loads, so it also bends. That's a frame member. The whole game is picking a smart free body and writing those 3 equations. Concept 2. Beams. A recap. A beam carries transverse load and bending, and you already built this in Week 1. Two results come back when a frame member bends. The bending stress, moment times c over the moment of inertia, largest at the extreme fiber, and deflection, which you read straight from the Handbook's beam table rather than deriving. That's all we need on beams. The real work here is trusses and frames. Concept 3. Trusses. A truss is a triangulated set of two force members pinned at the joints. Here's the honest part. The Handbook prints the equilibrium equations, but not the method of joints, or method of sections as named procedures, so commit the steps to memory. Method of joints isolates one pin and writes two force equations, so 2 unknowns at a time. Method of sections cuts through at most 3 members and takes moments about a smart point to get one member directly. Sign convention. Tension pulls the joint in. Compression pushes out. Concept 4. Frames and machines. When a member takes 3 or more forces, it isn't two force, it bends, and its pin reactions have 2 components. Frames hold their shape, machines move, but the tool is the same. Analyze the whole structure first for the support reactions, then dismember. Draw each member separately with pin forces equal and opposite across each joint. And always look for a two-force member hiding inside the frame. Its axial only direction is a free unknown, eliminated. Setup. The worked truss. 3 equal panels, 4 meters wide and 3 tall, which makes every diagonal a clean 3-4-5. Pinned at A, roller at D, with 12 kilonewtons hanging at each of the 2 interior bottom joints. The loads are symmetric, so each support carries half the total. 12 kilonewtons up at A and at D, and no horizontal reaction. From here it's joints and a section cut. Solve. Part 1. Method of joints. Start at joint A, because it has exactly 2 unknown members. Sum of vertical forces gives member AE at 20 in compression. Sum of horizontal gives AB at 16 tension. Move to joint E, where AE now pushes in along its diagonal. The horizontal balance gives the top chord EF at 16 compression, and the vertical balance gives the vertical BE at 12 tension. 4 member forces, all from force equilibrium. The negative signs simply mark compression. Solve. Part 2. Method of sections. Cut straight through the center panel, keeping the left piece. The cut crosses the top chord, the center diagonal, and the bottom chord. Take moments about B, and the bottom chord and diagonal drop out, leaving the top chord at 16 compression. Take moments about F, and the bottom chord comes out at 16 tension. Finally, sum vertical forces. The panel shear here is 12 minus 12, 0. So the diagonal carries nothing, a genuine 0 force member. The chords match the joint answers exactly. Solve. Part 3. A frame pin reaction. A horizontal boom is pinned at the wall and held by a cable from its tip, with a load hanging at midspan. The cable is a 2-force member, so take moments about the pin. Its vertical pull balances the load's moment and gives 5 of tension. Then horizontal and vertical force balance give the pin reaction, 4 across and 3 up, 5 total. Both components are non-zero because the boom bends. A truss member never would. Traps. 5 ways this bites. 1. Two force is a truss assumption. A frame member that carries a load between its ends bends, so don't call it axial. 2. Mind the signs. Tension pulls the joint in, compression pushes out, and a negative answer just flips the sense. 3. A section cut needs 3 or fewer unknowns, and pick the moment point that kills 2 of them. 4. Zero force members are real. 0 under one load case, loaded under another, so keep them. 5. Dismember frames properly. Whole structure reactions first, then the members, with pin forces equal and opposite. Quick recall. It all reduces to force and moment equilibrium. The method only chooses the free body. Method of joints takes 1 pin and 2 force equations. Method of sections cuts 3 members and takes 1 moment equation for 1 force. A truss member is 2 force, axial along its axis. A frame member is multi-force, so you dismember and match pin forces across joints. Beams are the week 1 recap, bending stress and table deflections. Golden rule. Name the free body first, then write the same 3 equations. Next up, Lesson 8. Basic machines and mechanisms. Trusses and frames hold still. A mechanism moves. We'll cover simple machines and mechanical advantage, instant centers for 4-bar and slider crank linkages, and the pins and retaining rings that hold a mechanism together in shear. Everything's at PEPrepengine.com. Cheat sheet, word solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at PEPrepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.